Hi, algebra students. These are your notes for section 3464 on arithmetic and geometric sequences, day 2. So, remember yesterday we talked a lot about how to determine if a sequence was arithmetic or geometric, then how to find the next 3 terms in the sequence using either the common difference or the common ratio. Today what we're going to do is use a formula to help us write an equation for either of these types of sequences. So just keep in mind that this formula is just like any other formula that we work with, such as our area formula, perimeter, volume, things of that nature. So it does have some letters in here which we need to define, okay? So we're going to start with a formula for an arithmetic sequence. So in this formula, we read it as a sub n equals a sub 1 plus the quantity of n minus 1 times d. And each of these parts is important to understand. So the first part of our formula is a sub 1, and that stands for the first term in the sequence. Okay, then we have n, which represents the number of the term that we are wanting to find. Okay, and then we have d, which is our common difference. Remember, that's the number that we are adding every time. So you might be asking, well, why do I need this formula? Why can't I just, add that number each time and extend the formula? So this, the formula is really helpful when we're trying to find a number of a term. Like, let's say we wanted to find the 50th term in the sequence, then we wouldn't want to use our calculator and keep hitting plus 2, plus 2, plus 2, plus 2. So using the formula is really helpful to weigh mathematically we can get to the answer more quickly, okay? Let's look at our next formula. This is a geometric sequence, and for a geometric sequence, we're going to start with the formula, which is g sub n equals g sub 1 times r to the n minus 1. In this formula, g sub 1 is again the first term in the sequence. Then we have our n, which is again the number of the term that we are solving for. And then finally r, which we've already talked about, is our common ratio. All right, so now that we've seen our formulas and we understand them, let's go ahead and get started. So our directions say identify each type of sequence and then use the correct explicit formula in order to find the unknown term. So just like yesterday, we look at the numbers in the sequence to determine if I am adding the same number or multiplying by the same number, or in some cases neither. But I think today we've got all of these are sequences. So for this first one, I can see that this is, not arithmetic. This is a geometric sequence. Therefore, it is going to have a common ratio. So what I notice is I'm multiplying by -2 each time. So every time I'm multiplying by -2. 8 times -2 is -16. -16 times -2 is 32, and so on. So therefore, my common ratio, which we identify as r, is -2. Okay, yesterday we talked about the first term, and today you're going to see why it's important that we identify the first term. So here, g sub 1 is 8. So then it says use the explicit formula to find the 10th term. So what I have to do is start with my formula. I'm always going to encourage you to write the original. So g sub n equals g sub 1 times r to the n minus 1. And then what we're going to do is just plug in what we know. So using this formula, first of all, if I'm going to find the 10th term, then the number 10 gets plugged in anywhere that you see n. So we're going to say g sub 10 equals 8 times our common ratio, which is -2 to the 10 minus 1. Okay, now, as you can see, our calculator is going to be our best friend tonight. So this is not super hard math. It's just a matter of plugging it into your calculator correctly. So I'm going to simplify here. In my calculator, I'm going to do -2 to the 9th power and then multiply by 8. And you should be able to do this all in one fell swoop, which is fine. And I believe our answer is negative 4,096. Okay, all right, let's go to number 2. This time, I believe we have an arithmetic sequence, which means we're finding a common difference. So if you look, this time we are, I believe, subtracting 13 every time. So 77 minus 13 is 64, minus 13 is 51, and so on. So we're going to say our common difference is negative 13. The first term, which this time we call a sub 1, is 77. And then I'm going to use my explicit formula to find the 11th term. So again, I'm going to start with my formula. So it is defined as a sub 1 equals, it's a sub n equals a sub 1 plus in parentheses n minus 1 times d. Okay, and again, I'm just getting that formula from up here, but I just have it memorized because I've used it so much. So we are looking for the 11th term. So that's going to go in place of n anywhere we see it. A sub 1 was 77. And our common difference was negative 13. So again, let's make sure on this one we're using order of operations. So I'm going to subtract inside my parentheses. So that's plus, and then we have 10. And make sure you see this here, we're multiplying by negative 13. So we have to do that before we can add the 77. So a sub 11 equals 77. And then that gives us plus, and actually I could do minus, it's negative 130. Let me fix that. Okay, and then so if I do negative 130 plus 77, we get negative 53. So our 11th term is negative 53. Okay. All right, I would like you to try these two. I would encourage you to pause the video. I'm actually going to amend problem number 1. We're going to get rid of the 1/2 and just start with 2 as our first number in the sequence. I'm going to ask you to pause the video and complete these two, and then you can start it when you're ready to check. Okay, hopefully you've had time to do those or you watched me complete these problems. Look them over, and then we're going to move on to the real life application. Pause if you need to and backtrack. So let's start with number one. It says an online store charges $5 to ship one box and $10 to ship two boxes. So the first thing I'm going to encourage you to do is create a table. All right, so the numbers in our sequence are 5 and 10, and we talked about this yesterday, that the x value, remember, again, we're just creating a table of values, so it's like you have inputs and you have outputs, so it's an XY table, but instead we're talking about a sequence. So our inputs, we're going to call n, which is the number of the term, and then our output is a sub n. Okay, so our outputs are the numbers in the sequence. So in other words, the first term is 5, the second term is 10, and so on. Okay, so we could keep going with this. Now, the important thing about this problem is it says write an explicit formula for an arithmetic sequence that represents the amount the online store charges to ship n boxes. So it's important that they're telling us that it's an arithmetic sequence, because with only two terms being given, we're not really sure if we're adding 5 or if we're multiplying by 2. So if we're adding 5, then again, we know that the next term is going to be 15. We want to find a formula that would help us find any number. So like if I wanted to ship 1,500 boxes, how much is that going to cost me? So let's go ahead and get started. So because this is an arithmetic sequence, I'm going to start with my a sub n equals a sub 1 plus n minus 1 times d. So we're just going back to our formula. And this time, we're just going to leave it as a sub n. The only two things we're going to put in at this moment is, again, it's just what we know. We know so far, we know that a sub 1 is 5. That's the first term in the sequence. And we know that our common difference is also 5. Okay, so we're going to plug that in. So we're going to put 5 here. And we're going to put 5 here. Okay, now with an arithmetic sequence, I'm going to go ahead and simplify this, because I can distribute this and combine my like terms, and I can clean this up a little bit. So I'm going to go ahead and clean this up. So my final answer in simplest form, combining my like terms here, would just be a sub n equals 5n. Okay, so that's my answer for the first part. Now using that, I'm going to determine how much it would cost to ship 11 boxes. So if a sub n is equal to 5n, then a sub, whoops, I wrote that wrong, a sub 11 must equal 5 times 11. So my answer is $55. It's going to cost $55 to ship 11 boxes. Okay, so that one not so bad. Let's go to this one. Number 2, a pendulum swings 80 centimeters on its first swing, 76 centimeters on its second swing, 72.2 on its third, and 68.59 on its fourth. So just like I did before, the first thing I'm going to do is create a table. So let's start with that. I'll try not to mess this up. I don't have as much space. So our first term is 80. Term 2 is 76. Term 3 is 72.2. And term 4 is 68.59. Okay, so the first thing I need to do is decide if this is an arithmetic or geometric sequence. And when I'm looking at this, I'm pretty sure that it's not an arithmetic sequence, but it's not an obvious geometric sequence either. So I need to see if there is a number that I can multiply each time that will give me this pattern. So anytime I'm working a hard problem like this, I say always think about how can I make it easier. So I would go back and maybe look at one of these easier problems. Let's take this problem, for example. And my pattern was 2, 4, 8, 16, 32. So I would say, assuming that I don't know that I'm multiplying by 2, how could I work backwards to figure out that I'm multiplying by 2? Well, the opposite of multiplying is dividing. So I'm going to think about that, like how could I use division to figure out the common ratio? So, and then let's make it even easier. Ignore these first three numbers and just focus on the 16 and 32 and think about, would I divide 16 by 32 to get 2 or 32 divided by 16? And of course, it's 32 divided by 16 that gives me the common ratio 2. So I'm going to try that down here. I'm going to go back down here. I'm going to use my calculator and I'm going to do 68.59 divided by 72.2. And I see that that gives me 0.95. So I'm going to assume that that is my common ratio, but I'm going to make sure by testing it. So I'm also going to test, I'm going to see if 72.2 divided by 6 gives me 0.95. And does 76 divided by 80 give me 0.95? And sure enough, it does. So now I know that 0.95 is my common ratio. So the next thing I'm going to do is finish this problem up. I know that G sub 1 is 80. And then I know my formula is G sub n equals G sub 1 times r to the n minus 1. So G sub n is equal to 80 times r, whoops, and again, I'm going to not put r, I'm going to put 0.95 because that's my number, to the n minus 1. So this is my formula. Now I'm going to finish this up by using that formula to find the distance of the 10th swing. Okay, so I just plug in 10 in place of n. So now I'm finding G sub 10. So 80 times 0.95 to the 10 minus 1. Okay, and then 10 minus 1 is 9. So I'm going to grab my calculator and put in 0.95 to the 9th. Whoops, it would help to turn that back on. To the 9th. And then times 80. Now, that gives me 50.41 something, 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 something. A big, long, non-repeating, non-terminating decimal. So what I'm going to do is just round that to the nearest hundredth. Okay, so it's 50 and 42 hundredths centimeters. Okay, so hopefully that helps with this assignment tonight. You are going to complete the practice that is in OneNote, and we will be reviewing during the block before your quiz later this week. So just let me know if you have any questions. Have a great night.